Hi people, notes 2.7 are on factoring completely. And so now we're going to take all the different types of factoring that we've learned and we're going to put it all together. So if you remember, we learned how to factor by factoring out a common factor. We learned about differences of perfect squares. We learned about perfect square trinomials. Here we've got simple and complex trinomials. I didn't split them up. They're the exact same process, so I didn't want to overcomplicate it. And we also learned about how to factor by grouping. So how are we going to know which one is which? So first of all, the greatest common factor, we're going to know it's a GCF, is if something is common. We'll know it's a difference of perfect squares. If you remember, there's three ways that we know. It's a binomial, there's subtraction, and we have perfect squares. We will know it is a perfect square trinomial or any of these types of factoring questions by either doing guess and check or by decomposition. If it works for us, then we can factor it. If it doesn't work, then we can't factor it. And then lastly, factoring by grouping, we'll be able to tell that it's possible if there's four terms. Again, just because there's four terms doesn't necessarily mean that it's possible, but it definitely, if we don't have four terms, then we don't want to factor by grouping, okay? And we're going to follow this decision tree, this flow chart, until we get to the point where we say, no, all done. Okay, so the first thing that we're going to do is we're going to look and see, is there a greatest common factor? So looking at this example right here, I can tell for sure that there is a greatest common factor because the coefficients have a 10 in common. I can divide them both by 10, but also the variables have a c squared in common. So I'm going to factor out 10c squared. When I factor that out of the first term, I have a d to the power of 4 left over. When I factor it out of the second term, I have a negative 16 left over. Now, when I go through and I look at the next part, I'm going to completely ignore my GCF. So it's like my GCF's not even there. And I'm just going to look at what's inside of the brackets here. And I'm going to answer these questions based on what's in the brackets. So in the brackets, I do have two terms. So I want to know, is this a difference of perfect squares? So in order for me to know if it's a difference of perfect squares, it has to be a binomial, which it is. We have to have subtraction, which we do. And we have to have perfect squares, which we also do. So I would go ahead and take this right here, and I would factor this as a difference of perfect squares. So d squared of d to the power of 4 is d squared. The square root of 16 is 4. And then we would have a plus sign and a minus sign. What do I do with this 10c squared? I just bring it down. I just copy it down because each line has to be equivalent to the line above it, and nothing's going to make that 10c squared cancel out. Now that we've done the difference of perfect squares, let's go back to our next step right here, which says, can you factor more? If you can, you go back to the start. If you can't, then you're all done. So let's go back to the start to see if I can actually do any more with what we have here. So I'm going to take a look at each one of my expressions here.
So that way you know what I'm talking about.
So first question is there a greatest common factor? In the orange expression here, there's nothing in common with the d squared and the 4. And same thing is true for the blue expression here. And to be honest, if you factor out the GCF correctly at first, you will never have a GCF in either of these terms here. So then I'm going to ask myself, are there two terms? So looking at the first bracket, yes, there are. Looking at the second bracket, yes, there are. So I want to see, is this a difference of perfect squares? The orange expression is not because of this plus sign that we have here. It has to be subtraction, which means that I can just leave the d squared plus 4. It is fully factored. But this d squared minus 4 right here is a difference of perfect squares because it is a binomial, has subtraction, and there are perfect squares. So what I would do is I would take this d squared minus 4, and I would factor this a little bit further. So the square root of d squared is d. The square root of 4 is 2. I would have a plus and a minus sign. Then I just copy down this d squared plus 4 that I have here because there's nothing else I could do with it, as well as this 10c squared that I have here. So let's see, are we all done? Well, we knew this was done. We knew this was done. Let's look at this right here. We have two terms, but neither one of these is a difference of perfect squares because D is not a perfect square, 2 is not a perfect square, and even though we have subtraction here, we have addition here, so none of these are perfect squares, difference of perfect squares, which means that this right here is my final answer. Okay, so can you factor more? Nope, I'm all done. And then it says check your answer by expanding. So let's go ahead and check our answer really quickly to make sure we did this right. So first thing I'm going to do is I'm going to expand what's in blue right here. It doesn't matter, you can do it in any order you want. So right here, D times D is D squared. D times negative 2D is negative 2D. 2 times D is positive 2D. 2 times negative 2 is negative 4. And then I'm going to copy the rest of this down. And I know that this negative 2D and this positive 2D will cancel each other out. So I end up getting D squared minus 4. Multiply that by D squared plus 4 with a 10C squared in front. Now I'm going to go ahead and FOIL this. So D squared times D squared is D to the power of 4. D squared times negative 4 is negative 4D squared. 4 times D squared is positive 4D squared, and then 4 times negative 4 is negative 16. Do not forget to copy down this 10C squared here. And sorry, I'm running out of room, so I'm just going to go horizontally now. And I know that this minus 4D and this plus 4D cancel each other out, so it's D squared minus 16, except I apologize, I wrote this down wrong. This should have been D to the power of 4. And then I can distribute this 10C squared through, and I end up getting 10C squared D to the power of 4. Multiply that by negative 16, I get negative 160 C squared, which is the original expression, so I know I did this correctly. Okay? Okay, so in our next example, we're going to use this factoring decision tree. And so the first thing we want to ask ourselves is there a common factor? Is there anything in common with these terms here? And although they don't have a variable in common, they're both even numbers, so they're both divisible by 2. So when I factor out the 2 from the 50x squared, I get 25x squared. And when I factor it out of negative 242y to the power of 4, when I divide it out, I get negative 121, and then I've got y to the power of 4. So I'm done with the greatest common factor. Then I'm going to count the number of terms. And looking at the terms that I have here, I have 2 terms inside of here. So I want to see, is this a difference of perfect squares? Well, there's subtraction. It's obviously a binomial because it's 2 terms. And we have perfect squares. I can square root 25x squared evenly. I can square root 121y to the power of 4 evenly. So this is a difference of perfect squares. So let's go ahead and factor that. So the square root of 25 is 5. The square root of x squared is x. So I've got 5x here. The square root of 121 is 11. And the square root of y to the power of 4 is y squared. And then I'm going to have a plus sign and a minus sign. And then I'm just going to copy this 2 down right here. Okay, cool. Then we look right here and we say, can you factor this anymore? So let's go back to the start and see if there's anything in common. So here I've got 2 terms, but it is not a difference of perfect squares because of the addition sign there. Here I have 2 terms, but it's also not a difference of perfect squares because I cannot square root 5 or x or 11. So that means that this right here is completely done. I can't factor anymore, and this is my final answer. All right, in our next example, we're going to go through our list just like we always have done. So greatest common factor, there is a c in common. So even though the coefficients have nothing in common, there is a c to the power of 1 in common. So I'm going to factor that out. And when I take that out of c to the power of 3, I've got c to the power of 2 left over. When I take it out of 2c squared, I've got 2c left over. And when I take it out of negative 35c, I get negative 35 left over. And I'm going to look at the number of terms. So it is 3 terms. So I'm going to try to just factor it either by trial and error or decomposition. It is completely your choice. And actually, let's go up here, and I want you to just write yourselves a note that we would either do trial and error or we would do decomposition. So here I'm going to try to factor what I have inside of here using trial and error. So I know that my first will multiply together to give me c squared, so it would have to be c times c. I know my last would multiply together to give me 35. So let's make a list of factors of 35. 1 and 35, 5 and 7. Because this is 1c, when I do my outer and my inner, the coefficient here is going to stay exactly the same as the numbers that I have here, which makes it easier for me to choose my numbers. So I'll try 5 and 7. My outer is 7c, my inner is 5c. And I can get a 2c if the 5 is negative and the 7 is a positive. And then I just bring the c down right here. So, and again, I don't have to have the 1 here. So this right here is what I have. Now I would go here and see, can I factor any more? So looking at the c minus 5, it is 2 terms, but it is not a difference of perfect squares. The c plus 7 is also 2 terms, but it's not a difference of perfect squares. So this is as far as I can go. So this is my final factored, fully factored answer. Okay, I'm going to skip question number 3 for right now, and I want to take a look at 4 with you. And I'm going to be completely honest and straightforward with you. Number 4 is a really tricky question. So first thing I'm going to do is look and see, is there a greatest common factor here? So leading coefficient is negative, so I definitely want to take out a negative value. 12, 303, and 75 are all divisible by the number 3. So I'm going to take out a 3. In my variables, I can see that there are b's in common, and I've got b to the power of 2 for each one of my terms. So my GCF is going to have a b squared in it. When I factor that out of this first term that I'm looking at here, negative 12 divided by negative 3 is positive 4. That's why we factored out a negative value. So we have a positive number here, so it's easier for us when we factor the next step. And then I've got a to the power of 4. My b squareds completely cancel out, so I don't have to worry about a b squared there. The positive 303 divided by negative 3 ends up giving me a negative 101. I have an a squared here, and then the b squareds completely cancel out. And then lastly, this negative 75 divided by negative 3 is a positive 25, and then the b squareds cancel. Okay, so now that I've done that, I'm going to look at what's inside of these brackets here, and I'm going to count the number of terms. And I can see I have 1, 2, 3 terms. So I'm going to try to see if I can factor what's inside of here by either using trial and error or by using decomposition. So I'm going to use trial and error, but if you prefer using decomposition, go for it, doesn't matter. And I know that the first right here, when I multiply the firsts here, I should get 4a to the power of 4. This one's tricky because for 4, I've got a couple of options. I can either do 1 and 4 or 2 and 2. Let's start with 1 and 4 and see what happens. So I know that I could have 1a squared and then 4a squared right here. And then for my last, I know my last will multiply together to give me 25. So I'll make a chart for 25. So, sorry, I don't know why I wrote 2 and 5. I could either do 1 and 25 or I could do 5 and 5. So let's try 1 and 25 and see what happens. So I'll put 1 here. I'll put 25 here. Now let's guess, or let's check. So the outer is 25a squared. The inner is 4a squared, and 25a squared, 4a squared, no way will give me this negative 101a squared, so this is not going to work. But I can switch these because this 4 right here will affect what the outer and the inner will be saying. So here, instead of having the 1 here, I will put the 1 here, and I will put the 25 here. So my outer here would give me a squared, 1a squared. My inner here would give me 100a squared. And I can get negative 101a squared that I'm looking for here if these are both negative. So I will put a negative here and a negative here. And double check to make sure that this works. Negative 25 times negative 1 does in fact give me the positive 25 that I am looking for here. So then I can just copy down, don't forget this negative 3b squared is just going along for the ride. So I'm just going to rewrite this over here. So I get negative 3b squared times, here I've got a squared minus 25. And then here I've got 4a squared minus 1. Okay, then I'm going to ask myself, can I factor more? And the answer is most likely a yes. So let's look and see what we've got going on now. So the negative 3b squared, I'm not going to really touch. The a squared minus 25 has two terms, and it is a difference of perfect squares because I have subtraction. I have two perfect squares, and we already have established that it is a binomial. It has two terms. So that means that I'm going to use a, 5 and 5, because the square root of a squared is a, the square root of 25 is 5, and I'll put a minus and a plus. And then I'm going to take a look at this 4a squared minus 1, which is also a difference of perfect squares because it's two terms. It has subtraction, and I've got perfect squares here. So a square root of 4a squared is 2a. The square root of 1 is 1. I can put a plus sign and a minus sign. Doesn't matter what order you do it in. And then don't forget to copy down that negative 3b squared. Let's look and see if I can factor this any further. This is a binomial, but it is not a difference of perfect squares because a and 5, neither of those are perfect squares. Same is true here. For 2a plus 1, this is not a difference of perfect squares because there's addition, and 2a minus 1 is not a difference of perfect squares because 2a is not a perfect square, which means I can officially say that this is completely factored, and this is my final answer here. For question number 3, I'd like you to take a shot at this question. Try your best, even if you're not right, totally fine, but give it a chance, and then we'll talk about it next time I see you in class. That's it for this video. If you have any questions, let me know. Otherwise, I'll see you in class.